Okay, go ahead and just keep plotting those. Right now I'm just talking to Jacob and Nick. We're not here today. So we just take our sine table and plot those values on a graph. Sine and then cosine. Probably noticed it as you were filling out the chart, right? I mean, as you were filling out your table, what do you notice? Before you even drew the graph, I mean, just when you were doing the values, when you were doing this. Pattern, they repeat over and over. I mean, the pattern, 0, 0.5, this, up to a high point, then it's like back down, right? 0.866, 0.707, 0.50. Then they go negative, getting bigger, to there, and then back down to 0, right? I mean, which is just, but it's a unit circle. If you use the unit circle at all, I mean, that's what the unit circle does. And I'm going to show you a picture to make sense of this. But if you look at the unit circle, I mean, that's exactly what happens to the y's. They get bigger and bigger because we're going around the circle. So the y's are getting bigger there. Then they start coming back down. Then they go negative, and then they start coming back up towards 0, right? I mean, that's what's happening. So when we go around the unit circle, that's one thing. Because that's different though, right? Those are x and y, where x is the cosine value and y is the sine value. So we're plotting something different. Here, we're plotting, and this of course is what you got, right? For your sine graph, looks kind of like that, right? So this is a different plotting. The unit circle is plotting the x and the y both, the cosine and the sine. So we're not plotting the theta, we're plotting the x value, the cosine value, and we're plotting the sine value. Those two together make the unit circle. Here we're just graphing each one separately. So we're graphing theta as the x, so our angle is the x, and our sine value is the y. So this is called the sine graph. This needs to be committed to memory, right? This needs to be automatic. You know the sine graph, the basic sine graph by heart, just like you know y equals x squared. It's a basic parabola, right? Y equals x squared is a parabola. Y equals x is a line. I mean, this is just another in that we talk about families of functions and different types of graphs. We just add this to the list, the sine graph, okay? But again, it's got some properties as far as repeating. Now, what we're going to find out today is these 5 points are the biggies right here, okay? Now, where do those 5 points represent? Obviously, 0, what's this? Well, 1, but I mean as the theta. Pi halves. What's this? Pi, right there, 3.14, right? What's this one? 3 pi halves, 2 pi. So when it comes to the unit circle, 0, pi halves, pi, 3 pi halves, and back to 2 pi, right? It's like one time around the circle, okay? So that's what the sine graph looks like. So if we remember these 5 spots, it's kind of like, look at this, it's kind of like quadrant 1, quadrant 2, quadrant 3, quadrant 4, right? I mean, that's where those values came from, okay? Now, what would happen if we went around the circle again, you suppose? What do you suppose if we keep going on this graph? What's it going to look like? Same thing. He's just going to repeat it over and over. Because as we go around the unit circle and look at those y values, we get back to 2 pi, we're just going to repeat those y values all over again, same ones. So if we went back to this table and kept going after 2 pi, we would get all the same values again, right? And so we're going to probably get another, right, like so. Okay, so let me show you something here. So let's show the two together. So look what I got here now on my x-axis. I got 1, 2, 3, 4, 5. But now I've said, you know what? Pi halves, pi, 3 pi halves, 2 pi are so important that I'm going to actually label those on my x-axis. Okay, I'm actually going to label those. And to be honest, we'll get to the point where when we go to draw a sine graph, we won't, we won't even put in on a 1, 2, 3, 4, 5. Usually we'll put in a pi halves and a pi and a 3 pi halves, right? Because those are the really important points that we care about. Okay? All right, so watch what happens. I think this is really cool to show the connection between what we've learned here and what's going on here. Now, if I move P around, remember, there's the string right there. Now, that's a little past one. Let's reset that. But remember the string? That was about there, right? One piece of string went about there. Well, look what that is. That's 1 radian, right? That's 1 radian. And then, so on the x-axis here is radians. Okay, we go around again. Let's go 2 radians, right? 2 radians is right there. That was 2 pieces of string. 3 pieces of string took us right there, just short. Oh, missed it. 4 pieces of string, got it. 5 pieces of string took us to there. And then 6, right, took us right just short. And that's when we get all that stuff about, oh yeah, it's 2 pi all the way around, so forth, so on. Okay, now, this time let's show the sine. Okay, now as that line goes around, remember sine is the what? Sine is the y. So as we go around, this blue length is our sine. So the red is our theta, the arc length, and blue is the sine. And so all we're graphing here is red along here and blue on the y. And so look what happens. Blue's getting bigger and bigger and bigger until where? Until 1. That's the biggest y can be, right? So the biggest sine can ever be is 1, right? And that's why it peaks there. Now it comes back down. Now look at that blue thing. It's coming back down. Okay? And now it's back to 0. Quadrant 2. Now we're into quadrant 3. The blue goes negative. So that's what the sine graph does. Down to a low of -1. So the sine's output, the lowest sine can ever go is -1. Okay? And then back up. And now the blue segment's getting shorter and shorter and back to 0. And then if we went around again, it would just continue and keep doing it. Okay? So it's a neat connection with what we've done before. All right. So here's your basic sine graph. Now look what I did back here. Okay? It's going to repeat. So here it is from -2 pi to 2 pi. A lot of times we look at 2 cycles of a graph. We're going to write this in our notes here in a minute. Cycles. But that's what we call one repeating section. Right? A cycle. Okay? Notice in blue how I've put in the pi halves, the pi, the 3 pi halves, and 2 pi. So when we graph these a lot of times in the future, we're not even going to put in the 1, 2, 3. We're just going to make some marks, right? 4 marks. Each one represents a quadrant. Pi halves, pi, 3 pi halves, back to 2 pi. Okay? And that makes 5 important points. Your beginning, and then the end. Of course, 0 and 2 pi are the same as you go around, right? I mean, so that's why there's 5 points, even though they're just the 4 quadrants. Okay, because 0 and 2 pi are the same. You go back to here. So let's write down. So get your notes out. Let's go ahead and get your notes out here. And I would say in your notes, so your notes are not graph paper. So I would say in your notes, I would do something like this. So this is what I was saying, where sometimes we'll draw these graphs and we won't even use graph paper. We don't even need fancy marks to be able to graph the basic look of the sine graph. Okay? So y equals sine x. All we need are those marks there and a -1 and a 1. And again, one of the things you'll always have to remember, okay, because once we learn sine and cosine and tangent, you're going to have to remember the differences in the different graphs. Sine starts at the origin. Now, how do you know that? Well, sine of 0 is 0. If you think about an angle at starting position, terminal side right on the x-axis, sine of 0, the y is 0. So sine of 0 is 0. So that the sine graph is always going to start here. And then at pi halves, it's going to go up to 1. And then at pi, it's going to be back to 0. And then 3 pi halves, it'll be down to negative 1. And 2 pi, it's back to there. So we just go and we mark those 5 points. And we're done. I mean, we got it. We got it. There's our sine graph. And then we just connect. It goes up, comes down, goes up. Now, it's not 2 V's. It doesn't go, I mean, it's not, they're not straight lines. They get curved a little bit. Okay. There you go. I mean, we need, on command, you want to be able to graph a basic sine graph. Now, if you've struggled with the unit circle at all, knowing the sine graph can be a really nice thing. This is what I tell my calc class all the time, because sometimes it's been a year since they had calculus or advanced math, and they can't remember sine 3 pi halves. But they do remember the sine graph. Well, if you remember the sine graph, what's sine of 3 pi halves? There it is, right there, negative 1. Right? So if you can, so this gives you a way, other than the unit circle, to remember some of those points. That doesn't help you much for sine of pi 6. And what is that? I mean, that doesn't help a lot there. Okay? But for those ones right on the quadrant, pi halves, pi, 3 pi halves, a quick little sine graph can find those for you pretty nicely. Okay? Or you're solving an equation. Where does sine equal 0? Where does sine of x equal 0? Well, at 0, pi, 2 pi, right? Where does sine equal 0? Or to solve this equation, where does sine x equal 1? Well, you can think of the unit circle. Where's the y 1? Or you can think of the sine graph. Where does it equal 1? Oh, at pi halves. Pi halves, right? So you think of the sine graph, you can do that. Okay, now a couple other things let's put on here. Let's do domain and range. What's the domain of the sine graph? What are the possible x's you can have? All reals, or negative infinity to infinity, because this graph could just go on forever. The sine graph's just going to go up and down, wavy, up and down like that forever and ever. Keep repeating. What's the range? So like this. Between negative 1 and 1, or you could just go negative 1 to 1 like that, right? You can just go negative 1 to 1. The range of sine. So that's important to keep in mind, that sine can never be, can have an output bigger than 1 or greater than or less than negative 1. So that makes me think of another type of problem we sometimes see. Like on a no calculator quiz, you get sine of x equals 1.7. Find x. It's no calculator. Now, if you try to do that on your calculator, well, how would you type that in your calculator? No. Oh, not divided by. What do? Second sine 1.7. Right? That's how you find the theta. Now, we're not using theta, we're using x. But you do the same thing. Second sine 1.7, what do you get? You get an error, right? Why? Why do you get an error? That's the output of sine equal 1.7. When does that happen? Never. Sine can't have an output of 1.7. Sine has to have outputs that are between negative 1 and 1. That's no solution, right? Sine will never equal 1.7. That'd be like your sine graph being up here. When's your sine graph going to be up here at 1.7? Never, right? So sine has a range from negative 1 to 1. It means the output can't be outside of that, negative 1 to 1. Okay? All right, notice it's an odd function. It's got origin symmetry. Origin symmetry. Remember, you put in pi halves, you get 1. You put in negative pi halves, you get negative 1. Opposites in, opposites out. Sine is an odd function. Origin symmetry. Now that can be helpful too. You want to do sine of, now to be honest, it's not real helpful if you're struggling with the unit circle anyway, and I'm not sure it's a big help, But sine of negative pi 6, how should that compare to sine of pi 6? How should those two compare? Odd function, opposites in, opposites out. They should be opposites, right? So if you're asked on a no calculator thing to do sine of negative pi 6, sure, you can draw it, put it down in the fourth quadrant. We can do that, that's fine. But if you know sine of pi 6 is 1/2, you say, well, that's got to be negative 1/2 because they're odd functions. They got to be opposite values, right? I mean, that's just, again, it's not anything new. It's just another way to look at stuff we already know or have already have a way of doing. Okay, let's go to your cosine graph. Hopefully we've had a chance here to put those values in. And the difference here is this one starts at 0, 1, doesn't it? And then we go to 0.5 and 0.8. And then we go to 0.7 and 0.7, which was a point we had on the sine graph, but it was going the other way. 1 is about 0.5. Oh, whoops, that should have been up here farther. Okay, and 1.57 is 0, and it's coming down like so. Well, it looks like this. Right? Everybody got theirs to look like that? Okay, now if we continue on, right, it's just going to continue, isn't it? Okay, let's go back to our sketchpad document here. And now this time, as P goes around, we want cosine. Well, cosine on the unit circle is what? Cosine is the x. Cosine is the x. So this time as we go around, the red is our theta. So the red is our angle, our radian, and the green is our x. So what happens? It starts at a 1 way out there. So the green starts. Let's reset that. The green starts way out there at 1. And so as P goes around, what happens to that green? Starts getting smaller. So as we go around the unit circle, x gets littler and littler and littler until it's 0 there, and then it goes where? Then it goes negative. So as we go around the unit circle, now x is going negative. So sure enough, our graph is going to go down below the x-axis. Okay? And it's getting more negative until it gets to be -1, and then it's going to start shrinking. Still negative, but it's getting smaller, back towards 0. And then finally, and there it's 0. Finally, it flips over to positive again, getting bigger and bigger until it ends up back at 1. And now that's just going to repeat over and over. Now, if you drew out several cycles of this, is it going to look just like the sine graph? It's going to look just like it, isn't it? Except shift. I mean, basically it's shifting. And that's something we'll talk about more later on. But if we just want to look at the whole cosine graph, so let's go back to here. Okay, so there's 2 cycles. I went ahead and put 2 cycles of the cosine graph in here. Okay, but the difference is the cosine graph starts up at 1, has a y-intercept of 1. Okay, and it kind of makes sense that it would because of what we said. Cosine of 0 is 1. We know that from the unit circle, so we should always be able to remember where. And look at the important points again. Put them in blue. 1, 2, 3, 4, 5. That'll get you 1 cycle of the sine or cosine curve every time. 5 points, and you're back to repeating. Notice 1's on the x-axis. Now, we're going to do some stuff. Not today. We're going to talk about some squeezing and stretching these graphs, and then on Monday we'll talk about some shifting, moving around. Well, if you move this up and down, then these points won't be on the x-axis anymore. So let's talk about it being in the middle of the graph. These 2 points in here are right in the middle of the 2 peaks. That'll never change, right? As we move this graph up and down and stretch it and do all kinds of things to it, these 5 points will always be there. You'll have your peaks, and then you'll have your points that are in the middle of the peaks. And those are always like your quadrant ones, okay? So again, the red numbers are kind of the ones we want. So in your notes, right? So in your notes here, we're going to talk domain range in a minute, but in your notes, you can just go 1, 2, 3, 4, pi halves, pi, 3 pi halves, 2 pi, those are, and then here, 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 and here. And then you just make it curved, don't make it a V. Okay, and boom, you got your cosine graph. You got 1 cycle, 1 section of your cosine graph. Okay, what's your domain on the cosine graph? All reals, because this graph could go on forever and ever to the left and forever and ever to the right. What's your range? What's your range on cosine? Same as sine. Remember, range is your y's. The cosine graph's never going to go outside of negative 1 to 1. Okay? Sine and cosine are very much the same that way. Well, think about it. On the unit circle, your cosine is the x. The x can't ever get bigger than 1 or negative 1 on the unit circle. Okay? And the y, sine, can't ever get bigger than 1 or smaller than negative 1 either. All right, and do you notice how it's an even function? See how cosine's an even function? You put in pi half, you put in opposites, you get out the same thing. Opposites in, same thing out. That's an even function, like x squared. X squared, a parabola, it almost looks like a parabola right here. Right? Right here, it almost looks like a parabola. Right? It's an even function. It's got that y-axis symmetry. Right? It's got y-axis symmetry, which again can be helpful. If I'm asked to do cosine of negative 2 pi thirds, how does that have to relate to cosine of 2 pi thirds? How do those two answers compare? They are the same. They are the same, right? Because cosine's an even function. Now, if you look at the unit circle, sure enough, where's 2 pi thirds? It's right there. Negative 2 pi thirds is down there. Well, look at that. That's where cosine is negative in quadrants 2 and 3. The x on those two triangles is going to be the same. The x is going to be the same. Okay? So that happens to be 1/2 and 1/2. Right? I believe I'm right on that. It'd just have to be negative, wouldn't it? Negative 1/2. They're both negative 1/2. But that's what even function means. If you remember when we did odd even function stuff, we talked, the last thing we did was a function notation. We were a little cloudy on that, I think. But, it just meant opposites in, same thing out. The way we wrote it actually was f of negative x equals f of x. And that just means if they have opposite inputs, they have equal outputs. Okay? That can be handy. It's not necessary. We have other ways of figuring out cosine negative 2 pi thirds. We just draw it and we just get it. So we don't have to have that information. But there it is. Okay, so that's the sine and the cosine graphs. The basic looking graphs. We want to be able to sketch those at a moment's notice. No, not the calculator will help, not a regular calculator. Graphing calculator will. Okay, now, but before we go to lunch here real quick, one of the things we'll do as we go through this is do some work on Desmos. You've done that before with your graphing calculators. Let me just show you what we're going to talk about after lunch. So here I got a basic sine graph. Now you see your 1, 2, 3, like that. It's got 1, 2, 3. It's got your normal, so that cross right there, that's pi right there. But here's something kind of cool you can do with Desmos, exactly what I just did on my graphing. I say, I like that sine graph, but I don't want 1, 2, 3. I'd rather have pi numbers there. So right here under my tools, on my x-axis, instead of go by steps of 1, I'm going to go by steps of what? Pi halves. Now I can just, to get pi, just type pi. So you type pi, it turns into a pi. It's kind of cool. And then divide by 2. And now look what you got on your, graph. Okay, now you got your pi halves. You got your pi, 3 pi halves. You can't quite see the 2 pi in this one over here. So you got a nice sine graph. You can do those pretty quickly. So what we're going to talk about when you guys get back, so I know it's going to make lunch seem really long because you won't be able to wait, but so we're going to say what happens when you throw a 2 on the front, a 0.5, what happens if you put a number in there, right? But I'm going to keep you in suspense. I'm not going to tell you. You got to come back from lunch. I'm afraid you might sneak out, Jack, on a Friday. Come back.
We hate cliffhangers, Coach.
I know. I'm going to make you wait. Come on, ring bell. Stop the recording. Oh, thank you.
Stop the recording.
Okay. One of the first things we did was talk about function transformations. In other words, remember vertical stretches and compressions? No. Yeah, horizontal stretches and compressions, shifts, vertical. Okay, now, so what should a 2 on the outside of the function do?
Vertical stretch.
Vertical stretch. Okay, so let's review that. So multiplying on the outside, remember outside affects the outputs. So the y values. So a multiplication on the y value is going to be a vertical stretch. If it's less than 1, it'll be a compression. On the inside, remember it was horizontal stretch or compression. And it was opposite. Whenever it was on the inside, it was the opposite of what it was. So if you had a 4, it would actually compress. So let's just see those in action. And then how are you going, because the next quiz we take and then the test we do over this part of the chapter, you will have to be given something like this and sketch them by hand, right? Or the reverse of that. Here's a graph. What is the equation of that graph? And that's one of the things we'll be working on, right? And then there'll also be kind of some matching. Maybe here's some equations, here's some graphs, match the equation of the graph, that kind of thing. So this should take the sine graph. So once we know, just like parabolas and any of those other ones we were doing, once we know the basic sine graph, you put a 2 on the outside, what are you going to do? Well, you just take those same important points we talked about, okay? 1, 2, 3, 4, well, there's more than that because I got 2 cycles. But if we go over here, actually let's just focus on the one over here on the right side. So what's going to happen? This is going to stretch too. Well, it's already at 0, so it stays at 0, right? The stretch, remember, goes above the x-axis and then the stretch is down below. So this one that's at 1 is going to go up to 2. That's going to stay at 0. That's at 1, going to go down, or -1, going to go down to -2. So it stretches there and there, okay? Just like we had done before. And likewise, a 0.5 is going to compress the graph, okay, by a factor of 2, or a 1/2 is how we would normally see that there. Okay, so this was up here at 1, it squeezes down by a factor of 2. So it was at 1, it's now at 1/2. Here it was at -1, it's now up here, so it's compressing for both directions. Okay? All right, and then you guys also, we talked about horizontal, right? Now, this is going to have a special name. We're going to talk about this here in a minute when this happens. Okay? So there's the purple graph, right? Compressed. Remember, a 4 is going to be the opposite. Since it's on the inside, it's the opposite. It doesn't stretch 4, it compresses 4. Okay? So what the 4, another way to think of the 4 is, remember we said there was one cycle for 2 pi? There was one cycle, went up, came back, went down, came back to the starting point. There was one cycle in 2 pi. When you put a number on the inside, think of that as how many cycles per 2 pi. So when there's a 4 on the inside, that's how many cycles. So if you look, 1, 2, 3, 4 cycles of the sine graph in that 2 pi. But in effect, what it did was compress. Okay? So it's a way to think about that. You don't have to necessarily know that. I'm probably not going to ask you that question. But now, how do we do that? How do we do a compress? Well, if you remember, what we did is we said, well, pick some of the important points. Well, of course, on this graph, we know what the important points are. It's going to compress in towards the x-axis, or excuse me, the y-axis. So this that's here at pi halves, now luckily I've got this is marked off in 4 units, right? So this one is 1, 2, 3, 4 of these boxes here. It's going to compress in a factor of 4. Okay, this point down here, which was, well, let's go to this point right here, which is 8 of my little marks is going to go in to 2 of those little marks away, right? Again, by a factor of 4, or 8 divided by 4. Okay, now we'll talk about another way to do that as well, but this is right here is pi 4s, right? This point right here is pi 4s. Okay, notice that point was pi. So if you're going to compress it in, it's going to go into a place that is 1/4 as much as that. So it was a pi, so that point's going to move into pi 4s. Okay, all right, so we'll work on doing those scenarios. Okay, what about this one? X over 2. Well, first of all, I wouldn't think of that as x over 2. If I was given it as x over 2, I would always write it like this. we always want to write it as an x with a number in front of it. So we want to write that as 1/2 x. So what's this going to do? Horizontal what? It's going to be a stretch. Remember, it's the opposite. So if you get a 1/2, this one compressed, this 1/2 compressed it vertically. This is actually going to stretch it by a factor of 2. Or another way to think about it, there's going to be half a cycle for 2 pi. Okay? There's going to be half a cycle for 2 pi. So only that first part of it. So again, that's a stretch. So this point right here that wasn't pi has been stretched out to 2 pi. Okay? All right. And then what about one like this? Let's put a pi in front of there. What's that going to do? Remember, pi is just a number. 3.14. It's going to compress it by a factor of 3.14. So just like this 4 did, right? Pi is just a number. Okay? So again, it's going to compress it. But what this means is there would be 3.14 cycles per 2 pi. So you got 1, you got 2, you got 3, and then a little more of a cycle. But the interesting thing about this is, where are these points actually landing? Okay, well, if we go back to our tools, now it looks like we don't want pi halves to be a mark anymore. Let's go back and do a step of 1. And let's see what's happening there. Oh, sure enough, look what's happening. One cycle goes right at 2. It was 2 pi before, wasn't it? And now it's, when that pi was on the inside, it now made one cycle go 2 units. Okay? So we're going to talk about that next. So if you get your notes back out, if you don't have them out here, but we'll go back to our notes here. Okay, so tangent, we'll deal with tangent later. All right. So, right here, we'll just focus on this part up here. So, what sine and cosine are called periodic functions. But I think we talked about this, didn't we? We talked about periodic functions. We talked about functions that repeat, okay? Functions that repeat different values, okay? So, P is called the period of a periodic function, okay? So, for sine and cosine, obviously, the period is 2 pi. Okay, the period of sine and cosine is 2 pi. All right, and that means that's one cycle. One cycle goes over a distance of 2 pi units. The sine graph looks like that. Now, usually we go from 0 to 2 pi to see it, but we could go any interval of 2 pi. Go 2 pi to 4 pi, 4 pi to 6 pi, or even if you just went pi to 3 pi. Right? I mean, that's going to be a distance of 2 pi. That's going to be a repeating piece. Okay? It'll just be a different looking piece than this. Okay? So, one period, 2 pi for sine and cosine. So, one cycle every p unit. So, when we compress and stretch them horizontally, that's going to change the period. Now, that's the only thing that changes the period, right? If you stretch them vertically, that does not change the period. Right? So if we go back, if we go back to this and we look at that, that still has a period of 2 pi. The green one still has one cycle in 2 pi. And so does this one. Okay? The yellow one still has one cycle for 2 pi. So vertically stretching them does not affect the period. Only a horizontal stretch or compress changes the period of the function. Okay? All right. So, let's maybe jot this down. This is what we just talked about, but this will be a chance to look at it. So what we will end up talking about here is those 4 different transformations. And we've already talked about them, but as they relate to sine and cosine. So this is just a chance for you to write it down. Okay? So you could have a number in front of the sine or cosine. Okay? You could have B, a number multiplied on the inside. That we said was the horizontal stretch or compress. What we're not going to talk about today is then the shifting. We'll bring that in next week. Okay, that's the C and the D. Okay, Now, usually we don't have all of those at once. We could. And notice on the inside, the b is factored out of the x minus c, because if it's not, then the c is not right. Okay, the shift is not right. The horizontal stretch or shrink, the b has to be factored out of the x to get the shift, and you'll see that when we get to, if we get to any of those. Those we won't see very many of those. Okay, and then the d on the outside is vertical. So the two that are on the outside, which is the a and the d, those are the vertical. They act like we think they would. Bigger numbers of a are stretches, and positive d's are up, and negative d's are down. On the inside, it's opposite. Positive b or bigger b's greater than 1 are shrinks, and smaller b's between 0 and 1, like 1/2, 1/3, those are stretches. Reverse. And same thing with C. Now, I put the minus in the thing. So if you have a -3, that's a shift to the right. So I guess technically the C is positive in that case. If I have x minus 3, the way I've written it, the C is 3. But hopefully we understand that from before. So if I have x minus 3, it's 3 to the right. If I have x plus 3 on the inside there, then it's 3 to the left. A lot of times those will be pi or pi halves, because a lot of times we'll shift them, units of pi, because those are easier marks horizontally. And then also remember, if the a or b, if we have a negative multiplied, then that flips it. So if you have a -2 out in front, not only does it stretch it 2, but it flips it vertically, right? A negative. And if you have a negative multiplied on the inside, it flips it horizontally, so we can't forget that. Okay, so the top two are really the ones we're focused on right now, okay, for tomorrow. Matter of fact, or for Monday. Matter of fact, we have 2 things we have to be able to do with these graphs. We're not going to get into more than that. So we're going to have to talk about the period. What has happened. We put those numbers in front, and then we're going to sketch. I think we're going to sketch a few graphs. Yeah, we're going to sketch a few graphs, but just on paper. It doesn't have to be on graph paper. Now, if you'd rather, and you want to take some graph paper, that's okay. If you want to do your assignment on graph paper, that's fine. Okay, if it's a little easier for you to do, you can do that. Okay, all right. So one last thing for our notes. Well, we'll do a couple examples together here. You can put in your notes. So if we have y equals 3 sine x, that number 3 is called the amplitude. Now, that's only for sine and cosine, not for other functions. So like when we were doing this before, and we said there's a number multiplied on the outside, we didn't call it amplitude. But this is kind of a term that comes from music, because quite honestly, if you're musically inclined at all, this is a real important use of sine waves, is sound waves. I mean, look very much like sine. They can be modeled by the sine function, okay? Because this is what we get into. And so you get terms like amplitude. Okay, now amplitude is the measure above and below the middle, right? It's not between the high and the low. The high and the low is a distance of 6. So the 3 is the amplitude. So it goes 3 above the middle, 3 below the middle. Okay, so that's a term that's a pretty basic term. That's going to be easy to remember. But that number in front, the 3, is the amplitude. Okay, and that's what the graph looks like. I don't care if you're on the graph, that doesn't matter. But because we just looked at one of those, right, on Desmos. So you've got that. And I encourage you to use Desmos after you've graphed the ones in your homework by hand, right? To check it, to play around. I mean, there's nothing wrong with that. Get on Desmos on your Chromebook and do that. But on your quizzes, you're going to have to draw by hand. So you need to get comfortable doing that. Okay, so let's talk. You don't need to write this part down here. But so I already showed you on Desmos what happens here. It's going to shrink it and changes the period. This says there's 2 cycles per normal period. Okay, so that was what we were already talking about. Okay, I'm going to show you what to do with this problem though. So if we were to, and then we'll do one together. So the normal period, let me see, yeah. So the normal period, if this is going to shrink, here's the red one is the normal cosine graph. Well, if that's going to compress this by a factor of 2, then this point here that's at pi halves is going to go in here at pi fourths, which is going to be about there. This point, which is at pi, is now going to be in at pi halves. This point that's at 3 pi halves is now going to be at 3 pi fourths, which is going to be in here somewhere. Okay? And this point that's at 2 pi is now going to be half as much, or this point, excuse me, is going to be in here at pi. Okay? And so that's going to be in here like this. So what do we got? We got something that looks like this, and like that. Kind of a V, but anyway, you get the idea. Okay? So it's been compressed. All right? Now, what's the new period of that blue function? One cycle goes through what distance? Half as much, but what is it? Pi. The new period, the period of this is pi. Now, how do we get that? Well, there's a little formula right here. Now, this works for any of our functions. Don't worry about tangent right now. So if we have a number, we'll call it b, right? That was our number. So if we have a number on the inside, multiplied on the inside, for sine or cosine, the new period is very simple to get. We just divide. We take the normal period divided by b. The normal period divided by b. And that's the new period. So for sine 3x, the period will be 2 pi thirds. Okay, because that is compressed, there's going to be 3 cycles per 2 pi, so the period is going to be 2 pi thirds. Another cycle, another 2 pi thirds. Another cycle, 2 pi thirds. That makes 6 pi thirds is 2 pi. You have 3 cycles in there. So the period is 2 pi thirds. Now, if you put a 1/3 in there, we said that stretched it by a 3 factor. Okay, well, look what you do. Just take 2 pi divided by 1/3, which is 6 pi. Sure enough, that didn't stretch it. Now the period is 6 pi. So you got 1 cycle through 6 pi. Okay, so you just take the normal. So whenever you have a number in here, just take the normal period, which is always 2 pi for sine and cosine, and divide by that number, and that gives you the new period. Okay? Now, what that allows you to do then, we'll go ahead and graph one here. Well, first let's do one other thing first before we graph one. Okay, so that's just how we find the new period. Okay, whenever we've compressed the sine or cosine graph. Okay, so let's do 3 quick problems here. So your homework's not very long, and it's just got it's got 2 different parts to it. So the first part is they're just going to give you an equation, and they're going to ask you what's the amplitude and what's the period. Okay, what's the amplitude and what's the period? So based on what we just talked about, see if you can get those. Okay, so amplitude's pretty straightforward, right? What's the amplitude on this one? 2. What's the amplitude on this one? 1/2. Amplitude on this one? 5/3. The number multiplied in the front, the A, right, in front of a sine or a cosine is the amplitude. And again, that just means instead of the graph going from -1 to 1, up and down, bottom to top, the range, first one's going to go from -2 to 2. This one's going to go from -1/2 to 1/2. This one's going to go from -5/3 to 5/3. I mean, that's basically what the amplitude means. That's how far to go above and below the middle. So that's the stretch or compress. Okay? But we don't have to think of it as a stretch or compress really with sine and cosine, because sine and cosine is so easy because it's got -1 and 1 as its bottom and top. So when you stretch it, it's just going to be a factor of 1, and so it's just going to be that number. Okay, -2 to 2. Okay, the period's a little trickier one, and what do? You just take 2 pi divided by that number that's on the inside. So 2 pi divided by 1/4 is 8 pi. So the period of that one is 8 pi. So that's going to be a stretch, because that means one cycle is going to go through 8 pi. Okay? 2 pi thirds. This one's going to be a compressed. One cycle is going to get done at 2 pi thirds. Way short of 2 pi. 2 pi divided by 3. Now this one's a little tricky. When that x is up top, remember what I said? I'm going to think of it as this. Pi halves x. Pi halves times x. So I'm going to take 2 pi divided by pi halves. 2 pi divided by pi halves. So you flip. What happens? Pi's cancel. You get 4. So now the period doesn't have pi in it at all. Now the cycle is just going to go one cycle through 4. Not 4 pi, just 4. Remember, 4 pi is like 12 something. Or maybe even 13. That's like 12 something. Okay? 12 pi, or 4 pi is different than 4. Okay? 4 pi is different than 4. Okay, so make sure you understand that distinction. Okay, so that's one part of your homework. Here's the next part of your homework, is to just graph something like this. Okay? Just graph something like this. So let's do these two together here. Okay, now two for you to try. You don't need graph paper. You can get graph paper. That's fine. Okay, but let me get rid of my marks here. Right? So now it looks like your paper, right? I just make a little thing, put it. Now, to be honest, if I was doing this, I wouldn't even have marks on here yet. Okay, I mean, you guys don't have them, so let me get rid of mine. Now, I think it says 2 cycles. I think it says to do 2 cycles, so I don't care if you do them back this way or the other way. Okay, so let's just say you made this right here on your paper. Okay, so now I'm looking at the 3, right? And what do I know is going to happen then? It's going to stretch, so it's going to go up 3, and it's going to go down 3, right? So I'm going to make marks like that. Okay, then I'm looking at the 2. What does that do? Shrink, but more importantly, it tells me I have a new period, which is going to be what? 2 pi divided by 2, which is pi. Now we go back to what we said about the sine curve, and we said the sine curve has these 5, going way back too far. Said the sine curve has these 5 important points, right? Broke up into 1, 2, 3, 4 marks, right? So where's my last mark going to be? My last mark's going to be at pi. So what I usually do is I just go 1, 2, 3, 4 marks. Every sine curve is going to have it. Every sine curve, one cycle is going to have those 4 marks. It's going to have the start, and it's going to have that. Well, I'm going to make that one's pi. Once I know the period, that one goes out at the end. So what's the middle one? Got to be half of that. Pi halves. Then what's this one? That's got to be half of pi halves. Got to be pi fourths. And then what's this one got to be? Now you just count. 1 pi fourth, 2 pi fourths, 3 pi fourths. There you go. That's how you do it every time. Piece of cake. You figure out the period. 1, 2, 3, 4 marks. The period goes on the last one. That's pi. The middle one's got to be half of that. So divide by 2, pi halves. That one's got to be half of that. And now that's 1 mark. You want this one, so you go 1 pi fourth, 2 pi fourths, 3 pi fourths. You got them all. Can't fail. Nobody will ever miss one of these. And where do we go with the sine graph? Where does it start? Sine graph starts at 0. Where's at the next mark? Where am I at? I'm at the peak, which we know has to be 3 on this one because it's been stretched. Then at the next mark, I'm back to the x-axis. Then the next mark, I'm down here. And the next mark, I'm back where I started. And you got your nice sine graph Just that easy. Now, every one of you, so it might happen that every time you draw a sine graph, it looks exactly the same size, right? But it's not really because you've got different labels here, right? So it's not really the same size. Only if you overlaid it on top of another one would you even notice that. Okay? All right, let's try one more. So you got 1/3 cosine pi x. Okay, so again, let me get rid of these marks. Okay, I'm just going to put in the marks I need. Now, what's 1/3 mean? Shrink. But you know what? I'm not going to get real picky with you. How about we just call that 1/3 and we call that negative 1/3? You see what I mean by it's not really going to be the scale? Every graph's not going to have the same scale. Okay? Now, if I give you a graph with the scale already made up, then you're going to have to fit that in, and we may do that as we get better at it. But right now, I'm just going to do this. I'm going to say, hey, that graph's going to go to a peak of 1/3 and down to negative 1/3. Okay, what's a pi do? So the period's going to be 2 pi divided by pi, which is 2. So the period of this is going to be 2. So what do I mark on my x-axis? 1, 2, 3, 4 marks. What's the last one? 2. The period. What's the middle one? 1. What's this one? 1/2. Not pi halves, but 1/2. That's different. And what's this one? 1 1/2 or 3/2. I don't care what you label it. You use decimals if you want. And this is a cosine graph. So where's it got to start? Got to start up here. The cosine graph starts up here, doesn't it? And then where's it go? To the x-axis. Then down. Then back to the x-axis. And up. Those 5 points. That's all you need for the sine and cosine. Now, it's one cycle. Now, I did tell you in the homework they're going to say do 2 cycles. So you'll just make 4 more marks and just keep going. Or you'll go backwards and put them in the negative. I don't care. So what's cosine do? It kind of comes down. Goes like this. Like so. Got it? Every one of those graphs, if you identify those marks, it's easy to do. Okay? All right. So, homework. Page 326. Okay, so 5 through 18 is just amplitude and period. Write down the amplitude and period. Right, so you do the 2 pi divided by b, amplitude. And then the 39 through 47 odd is the graphs like we just did.